Hi there. Let me explain the files. First of all, ABC, it's the main file. I will discuss about it later. And here is the this file, admit. This file actually take into account the line data and load data. Okay, here is the load data, line data, and line data and load data. Here are two files. You can see them later. So in next file, feed power. uh, in feed power, this is our main file, because we have to uh, take our DG size and locations. Both variables are actually random variables, and we have two limits, lower limit and upper limit. So we have when our optimization techniques will help to normalize, or you can say our optimization technique will help us to make a stack or you can say to make an array. And then when we have the data, then we will put into the feed power, and this feed power will take into consider the DGs. So I mean, uh, our ABC optimization will help us for ridge size and hill climbing optimization will help us to define the locations for for our solution. So ABC will give us the optimal size, and then when we have the data, then we will put into this function. Actually, I have different video tutorials in which I have already mentioned feed power, working off without DG, and MIP bus, and I already have shared with you that, so you can take help from that. So in this video tutorial, my main focus is for this loop. So I will explain this loop. So first of all, start bus line data, load data, calculate load analysis. With this all the process is about without DG file, which I already have explained, so no need to explain it further. And next, I have to initialize DG incorporation of ABC. Let me focus on it. Here is the ABC file, that is our main file, and number of decision variables. And number of decision variables means, actually we have a in this program we have a choice that we can select from 1 DG to 4. So that's why we have put NVAR maximum and NVAR multiply, and here where size VAR size is actually 1, and next NVAR 4 multiplied by 2 1 8. It means we have one row and we have 8 columns. So 8 column means first 4 will represent the DG size, and next 4 will represent the DG locations. It is our choice later that we how much we want to incorporate. If we want to include 2 DGs, then uh, this matrix will be have 4 values. First 2 will represent DG size, and next two will be DG location. So next we have some ABC settings, and these settings I have made to make program run in few minutes. So in different programs this will be different. So here we have initialization for ABC matrix. So here is a hill climbing loop for initialization, and here we have selection for power factor and DG size. And here is our main loop, create initial population. uh, Here you can see that this incorporation of ABC is starting from incorporation of ABC input data, colony size, iteration, decisions, variable lower bounds, empty b selection, structure initialize, digit size created by ABC, initial population creation. So first of all, here in this program, here you can see that we have in starting h double l, and this variable is actually what it represent. It represent hill function start points. So this line means we are going to the file hill func, and where is the file? Here is the file main. We are going to hill func, and we have starting points. And here how much we have start points? We have 5 start points. So we are getting into this loop hill func. So in here uh, we are actually now we are actually at this point, creation initial population creation. So digits as created by abc, we are going to hill climbing incorporation. When we are going to hill climbing incorporation, we are actually uh, going to this function hill function start points. Okay, so let me focus. Hill climbing operation up limit up low limits string into a number conversion, and number assigns as digit locations. So let me explain how this is working. We are going to hill func. So here we have a maximum because we are representing the locations. So here are we have 33 locations. Okay, so here we have to make loop correct, because here we have num1 is 1 sorry, num1 is 50, and low limit uh, is 1. It means it less than 50. And here is up limit is 33, and num2 is greater 50 is greater than 33 to make condition true. So next we are going to uh, size string into we have taken here 72 uh, comma 1. Why I have choose string 72 comma 1? Because I have tried it different way. So I want to execute the program in limited time, in a shorter time. So that's why I make it 72, so program runs smoother in it. So let me run up to this. So here we are size str1. We just take a look at this file. Let me run the main program. When I click on the abc is main program 0.75, you can see 4. And then we have, and when I click on the next, then we have a str, here str, and here you can see str. So str we have a 72 random values. We have choose random values, not fixed value. So these random values, and here if value is less than 0.5, then we will put at that point 0. And if that value is greater than 0.5, because all the values in the str is between 0 to 1. So if it is greater than 0.5, then we have 1. Why I have put 0 and 1? Because we hill climbing function is working in the bits. So bits, bits is always 0 and 1. So let me go into this. Let me run the program after this, and when I click on the continue button, then here you can see my convert str is ready. And sorry, let me click on the step button. My convert, sorry, okay. So just a moment, let me execute the, let me run the program again. And okay, so here we have a str ready, and here you can see again that we have 72 values. And let me click on the step button. Sorry, let me, okay. So here you can see that we have str. At this point we have str ready, but we have no values for num1 2 3 4. So by this we are going to the file my convert. So let me go into the my convert file, and let me click on the continue button. uh, so my convert, in this file what we are going to do, we are going to convert string into number conversion. This is the point we are getting from the my convert file. So in my convert file, let me click on the run button. So program is starting it. So here you can see that our first we have string and we have 72 values. So first string we have 1, and the inter part, here we have the sign one integer, because it have one string. String from 2 to 3, we have two numbers, and that are 0 and 1. And the So I was actually at this point, so in 4 to 18. So let me check how are there 4 to 18. So 4 to 18 there are actually you can see 15. Okay, so here we have 15 strings from 4 5 6 7 8 to 18. We have all these strings in this way. So these are three for the I mean first locations, and second 19 you can see all the here, and here you can see this file my convert is what is actually going to do. It is going from string into number conversion. So number conversion, number conversion, sorry, conversion is here. So in the next part, we are convert for num1 is actually our first location as a dg1 for its optimal location for first dg, and num2 is actually refers to optimal location for dg2, num3 is for 3, and 4 for optimal location for dg4. If we made a selection of 3 digits, then it will skip num4 and it will consider num1 2 3. Okay, so here in this step, let me click on the contribute. We have int part 1 and dec part 1. So we are consider inc part 1, we are considering it, and we are considering it. We are let me click on the step, and here you can see num4, four nums are ready, and here you can see num1 is 4, num2 is 28, and num3 is 8, and num4 is 21. So again this file will result into string into number conversion, number assigned as dg locations. So now I have to do this part, number assigned as dg locations. So hill funk, we are back, and here we have merge, we have collect these numbers. Let me click on here, click on the continue. Okay, so sorry, continue, and here you can see num4 we have 21 14 3 9, and we have 4 locations for every iteration. For every next step, these values will be, let me click on the continue button one more time, and here you can see, now you can see that our locations are changed. So it is changed for every location. So here our HLL function, what is going to do, this function will number assigned as DG locations. Here step will covered, and in rand SCR what we are going to do, we are VAR minimum, what is actually, let me continue. So VAR minimum is 1, VAR maximum is 33, and NVAR is actually 4. So these next step, just a moment. So VAR minimum and VAR maximum we are considering from 1 to 33 megawatt, this next function. So here we are going into the feed power, PF our power factor that we have made selection above, and DGs we have 1 2 3 4, depends on us, and bus is 33, and pop I positions, what is actually that, pop I position is that. So our optimal locations is coming from this function, and our DG size is coming from this file. Okay, so in next function we have put all the values. Let me explain it step. So let me pop I cost, let me check where is pop, and in that you have to check the cost. So here we have a positions, and here you can see that first four 1 2 3 4, initially I have represent that the first four values are location, and next four are actually its size. Okay, I think. And then what is cost? Cost is that what is cost? Cost is actually when we are going into feed power, and you know that how feed power is works. Where is feed power? Here is feed power. In feed powers, we have put data over dg locations, here locations, and here is dg, uh, here is dg size as well. So this divided by 10 raised power 4 is converting into per unit, and here we have dg at specific points with specific power that we have taken from the optimization techniques. And then we have a load flow analysis, we have a Jacobian matrix in incorporation, and then next we have losses accordingly. So that losses is actually our cost. So that is our actually our where I have open it. I mean, for this combination, we have this cost for this combination of size and locations. We have a specific cost, and that is that. And when for 100 iterations, there are 100 variables. So in next step, this is our initial population, and then we have a newbie incorporation, and then we have a starting the newbie again we have locations taken from. So hybrid here hybrid optimization works in such a way, all the time we are taking locations from hill climbing, and our size is taken from the uh, ABC. And in the next step we have a newbie cost, and here newbie is already working in a similar way, just with some variations, and that variations is the base of this optimization ABC. We are not going to that. So here newbie cost, if newbie cost is less than pop I cost, here pop I cost means initial population, means initial population creation cost, and then we have newbie incorporation cost. And if newbie incorporation cost is better, then we will save newbie cost into pop I. What is that? It is actually our best position. And in the next step we have non-local bees with some fitness function and creation. So and then we have a comparison. If newbie if newbie dot here newbie is cost, if better, then what we are going to do, if our onlooker base result is better than UB incorporation, then we will say onlooker base result into pop I. And then we have a roulette wheel selection, that is a final step. And then we have a plot. So I think maximum things I have covered, and sorry for delay. Thanks for watching.